Hello class, these are our Algebra 1 notes. Today we are looking at section 7.3. We are solving quadratic equations with squared quantities. So to start out our solving, first we're going to go back and review absolute values. So recall that the absolute value of 4 is 4. And the absolute value of negative 4 is also 4. So if we're going to solve something like absolute value of x equals 4, we know that we have two answers then. We have x equals 4 or x equals negative 4. And again, the reason is if I take the absolute value of 4 or negative 4, if we put those inside our absolute value signs, both times they equal a positive 4. So the way that we're solving these absolute values is we make the quantity inside our absolute value signs. I'm going to write quotes, absolute value signs, equal to a positive and negative value. And then there's a couple here that are review that you're going to try on your own. So I would go ahead and try them on your own, like pause the video and then go back and check your answers. So for number 1, we're going to take the part that's inside the x minus 7, and we're going to set it equal to both 4 and negative 4, and solve them both. So x equals 11, or x is equal to 3. For the second one, we would take the part that's inside our absolute value signs, the x plus 3, and we would make it equal to 17 or negative 17. All right, so now we're looking at new stuff. Now we're looking at squared quantities. And the first thing that we're going to do is give you a definition. We're going to tell you that if we have an x squared, so the x squared is on the inside part, that's what happens first. So if I have an x squared and then I take a square root of my x squared, it equals to an absolute value. So this means if I have something like x squared equals 36, the way that I get rid of a square is with a square root. Those are inverses. And so I would square root both sides. But now my definition says the square root of an x squared is equal to an absolute value. So on the left-hand side, instead of just having x, I'm going to have absolute value x. And then on the right-hand side, square root of 36 is just 6. So then I'm going to have to come up with my two answers. Either x is 6 or x is negative 6. So when I'm solving it, I have a squared quantity. First thing that we're going to do is we're going to isolate the squared quantity. And today I think they're all going to be isolated for you. Second is to square root both sides. And then third step is going to be absolute value. And the fourth step is going to be just solve. So let's just make sure we understand why we need two answers here. So if I take a positive 6 and I square it, so I'm putting things back in for x to show that they work. If I take 6 and square it, 6 times 6 is 36. So if I take a negative 6 and I let that equal to x, that would mean x times x is negative 6 times negative 6. That's also a positive 36. So when I have a square root by itself, it has to be positive. Square root of 36 is just equal to 6. But when I have an x squared first, I don't know which I squared. I don't know if I squared a positive number or a negative number to start with. So basically that square root of x squared is always going to equal an absolute value. But if I just have a square root, like I said, by itself, it's not going to be both a positive and a negative. So we have to be kind of careful. For number 3, let's go ahead and start out by writing x squared equals 25, and then I want to square root both sides. So on the left, because I have a square and then a root, I have an absolute value. On the right hand side, square root of 25 is just 5. but now I have to write x is equal to 5 or x is equal to negative 5. On the next one, first I need to isolate my squared quantity, so I want to get the x squared by itself by subtracting 4 on both sides. Then I have x squared is equal to 81. To get rid of a square, the inverse operation is to square root both sides, so squares and roots are inverses. Every operation has an inverse. If I have an x squared and then a square root, I have absolute value. Square root of 81 is just 9, and so x must equal 9, or x could equal negative 9. For number 5, my squared quantity is already by itself. I have some stuff in parentheses, square is on the outside. So my first step, if I have a square, my inverse operation is a square root. Just like if I have adding, I need to subtract on both sides, or if I'm multiplying, I need to divide both sides. So because I have this quantity being squared, I need to take a square root. So the square and the root, we know, make an absolute value. So now I have absolute value of the quantity x plus 5. On the other side, square root of 64 is just 8. So that means my x plus 5 is going to equal 8, or my x plus 5 is equal to negative 8. So let's subtract 5 on both sides. Either x is equal to 3 or x is equal to negative 13. Last one, I want to start out by square rooting both sides. And x squared square root, that just makes an absolute value. But what about the square root of negative 36? So a square root means the number, when I multiply it by itself, when I square it, I get negative 36. So the problem is if I multiply a 6 times a negative 6, that gives me a negative 36, but I'm not multiplying the same number by itself. If I multiply 6 times 6, I get 36. If I multiply negative 6 times negative 6, I get 36. So there's no way to multiply two of the same number. Remember, 6 and negative 6, that's not two of the same number. It's two different numbers, and get that negative. So this part right here is not possible. And because it's not possible, we're going to say that there is no real solution. It turns out that there is an imaginary solution. That's a whole other thing for another math class. We'll save that for Algebra 2. But there is no real solution here. So main ideas today. Remember, we went back over how to solve absolute value equations, so we're continuing with those. And then we have this really important idea that if I have an x squared and I take a square root, I get an absolute value. That's kind of the big important idea for today. And then remember, we spent a lot of time solving x squared equations. So you're going to be practicing this in class and on your homework today. As always, please make sure you get help. Please make sure you ask.